Introduction to Ethereum Development Tools. Module 1, Video 9. So, development tools streamline the process of building, testing, and deploying smart contracts and dApps on Ethereum. These tools are essential as they help us ensure quality, security, and efficiency. Remix IDE is a web based integrated development environment for Solidity smart contracts. Within Remix, you can write, test, and debug your smart contracts as well as deploy it directly to the blockchain. Truffle is a framework for Ethereum smart contracts which helps manage the lifecycle of Solidity projects from creation to deployment. Truffle also provides built in support for compiling, testing, and deploying smart contracts. It also allows integration with third party tools like Ganache and MetaMask. Ganache allows you to simulate a blockchain environment locally, like a personal blockchain for development and testing. Its key features are simulate full client behavior, quickly deploy contracts, inspect state and logs. MetaMask is a browser extension wallet for Ethereum. It allows users to interact with dApps and enable managing and transferring of Ethereum tokens. Users can connect and interact with deployed smart contracts also. To set up the developer environment, download and install the required tools for your project. Set up and integrate your code editor with other tools. Connect to local or public Ethereum testnet using MetaMask or Ganache. Now you can start developing. EVM smart contracts are written in Solidity programming language. Other programming languages are also used to write smart contracts for other blockchain networks. Contract structure includes state variables, functions, events, and modifiers. You can test your smart contracts using Truffle Test. Truffle provides built-in support for writing automated tests. Remix Test, which has a testing module to run Solidity tests. Third-party tools like Ganache allows testing contracts on a local blockchain. To deploy a smart contract, first you need to compile the Solidity contract code. Select the network to deploy to, sign and broadcast the deployment transaction to the chosen network. After deployment, the contract will have a unique address on the network, which you can use to access it. Components of dApps includes its front-end interface built with web technologies. The front-end interacts with smart contracts deployed on Ethereum. dApps are decentralized, running on Ethereum nodes across the network. Its use cases are in finance, gaming, supply chain, and many more. Best practices to maintain blockchain security are having your smart contract code audited by security experts. Test it thoroughly to identify potential vulnerabilities. Adhere to security standards for development. Consider offering bug bounty to incentivize security researchers. Ethereum development workflow includes planning and design. First, define the project requirements, architecture, and smart contract design. Then, go to code and test. Write, test, and refine smart contract code using development tools. Deployment. Deploy smart contracts to the desired Ethereum network. You need to build the front end interface for users to interact with the dApp. You need to monitor the deployed contracts and maintain the dApp over time. There are Ethereum developer communities like Ethereum Stack Exchange, which will help you during development of your dApps. You need to use version control systems like Git to manage the code changes. You should set up continuous integration to automatically test code changes. It can also build and package the dApp for deployment. Automatically deploy smart contracts and updates to the desired network. Some scaling solutions for dApps are layer 2 scaling solutions. Solutions like Plasma and state channels to improve